As you know, the C programming file extension is .c. A comment, single line comment begins with two forward slash symbols.
Mhm. The same with Java.
Yes, okay, I'm a single line comment, right? And forward slash and this and ends this. I I can go on for multiple lines, same as Java again. These two things remain same in C++ and Java.
Hmm.
Okay. Now comes like in Java, you import packages, right, to get some libraries.
Hmm.
Here, you don't import, but you include some header files.
Okay, got it.
And the header file inclusion always begins with the hash symbol. So hash, I say include, and then in angular brackets, I would, okay, IO stream. Oh, this is CPP. I need to teach you C. Okay, stdio.h. And the file name is enclosed in angular brackets. So now what I'm telling is, okay, I'm going to use some library from this header file.
Hmm.
All right. So always remember anything that you do in any programming language, not just C. I want you to understand some of the fundamentals about a running process. Okay, let's go through them first and write the program. Yeah. Now, what is a program? In simple terms, I'm not asking any complex questions. What is a program?
It is a set of directions to execute
That's
something.
right. Yeah, set of instructions, right?
Hmm.
Set of instructions to achieve a particular task. Now, what is a process? What's a process?
Um, it's the journey to get to a final output.
Yeah. So a program that you have written above, a program in execution is a process.
Hmm.
So here in this, if you have said, okay, print one, print two, you just want to print these numbers. But it is still not executed yet. It is you have written the instruction.
Hmm.
It, it's like you go to the terminal and you go to the terminal and saying ls. Okay, you have just written the command. You haven't pressed enter yet, isn't it?
Hmm.
Unless I press enter, then it won't run.
Right.
So when it's running, it's called process.
Got it.
So ls is also a program, right? Ls is also a program written by developer like you, and which does what it is supposed to. Now this is in execution. Now, importantly, who is running it? Who is running this, a program to a process?
The user?
The user. Now, who initiates, right? Who initiates to run?
The user.
The user, you're right. Now, who actually runs it? Okay, again, let me rephrase my question. Um, who is providing the platform to run it?
The computer?
You can be more
Or the
precise.
IDE?
You can be more precise. The IDE is helping us to write the code, seeing the colors, blah, and all that, but not, it's not the one who is giving you the platform to run it. Think more. You're right. You're going up. So first you said computer, then ID, even more. Think.
Console?
Console is a um, is a shell that lets you run the commands. Now, who right? So the shell or the console is actually run and driven by the operating system.
Okay.
So now the first step is your OS gives you that platform, but this alone is not sufficient. Okay.
Hmm.
So on top of OS, you need something called runtime environment.
Okay.
So, what you have said is the development environment. Right? So when you said IDE, it is integrated. What does it stand for?
Development environment?
Yes. So the integrated development environment allows you to develop applications, but not run them.
Okay.
So now you need a runtime environment which is always hidden from the user or developer. You don't see it.
Hmm.
So you have OS here. On top of OS, you have runtime environment. On top of it, you have libraries. On top of it is where your program is. Okay, so the stdio.h is one such library that our program wanted to use. And now, how how do I know that where to begin? So, okay, this is a C program and this is a Java program. You will begin always from the main method, right?
Hmm.
And in C, there's a small main with small letter M.
Hmm.
And in Python, the driver, it begins there. So who tells the operating system that, okay, this is a Java file, you always start your execution from this main. Okay, this is a C file and even cpp.cpp. Okay, this is a CPP file. You always start your process from M, the small main. Right? There should be somebody. It can't happen just, oh, okay, right? It's out of the blue, it doesn't happen. So there should be somebody to instruct that. So that's your runtime environment.
Right.
So unless the runtime environment is deployed on top of OS, you cannot run a C program.
Hmm.
So what is this runtime environment I'm talking about? Is your the C libraries that are built. Right? When you say there is a new programming language in the market, what do we mean by that? So yes, some set of people have written a grammar to how to write it. That's the syntax part of it, what we will be learning as part of this. The syntax of a language. The second important part is, okay, what's the difference? Why should I need to use this, or where should I need to use this?
Mhm.
So that part comes as your the core libraries of your language. Okay, the development team of the language has given you set of libraries for this purpose, and then they have defined the way to run it, where to begin, where to end, what to do. All those are also being written again as programs only,
Mhm.
So now that is being done by runtime environment. Now we will talk more about it as we move forward. This will be continuing a continuous discussion which we'll be doing. But I wanted you to understand, yes, the main method is something that's an entry point. Okay, this is an entry point.
Mhm.
Where did the color change? Something. Okay. Hmm. Okay. Then going back to the ID. Therefore, I need to write main function. And as you know, the function in many languages begins and ends with a curly braces. And now I want to say print something onto the console. Hello, hello. This is my and every line terminates with a semicolon, just like Java. You're
Mhm.
familiar with it, right?
Yes.
Hmm. And then we return a value. I talk about it a little later. Okay, so I saved the file. Now I want to know where this file located. Code hello Winkies. I need to move this to somewhere else. We have documents, users, and keys. Okay. So our program is here now. If I want to view it, cat program.c. This is what we have written.
Mhm.
Now, if I want to view in little colorful way, I think view will work. View first program.c. No, it's not giving any colors. I remember there is a new gen editor that has come for command line. People often use it these days. No commands need to be remembered. Okay, so the syntax is what we have written. So the language is written.
Mhm.
Now we need to make this understandable by your operating system. Okay, so this
Mhm.
is where the involvement of translation of the code happens. So when I say translation of the code, here is your source code. So we call it, the syntax is a source code. So this source code is written in particular language. So here in this example, it is the file extension is .c. This
Right.
alone cannot be understood by your system, by your hardware, or by your processor. Let me call it hardware. Okay. This cannot be understood directly here. Like it's same like, okay, a newborn baby cannot be understood by an old man or by a person like you and me. We don't understand that because he or she just yells, screams, shouts, or we don't know anything what they're saying. It's
Yeah.
same like that. Then we need people who can help us to translate this.
Mm-hmm.
So the very first step, what we do is from source code, we generate the object code .o. And this object code is still not directly understood. From here, we link and load any third-party libraries.
Mm-hmm.
So we do use LD loader and linker LL, I guess. So linker and loader. Once you link and load with other external libraries, you will have the ELF file, executable file actually. And this will be understood by your OS.
Got it.
So your OS understands only one format, nothing else. Like in case of Windows, right? In case of Windows, it is exe. You know that, right? So exe is what the file extension is .exe. It is understood by Windows. It runs, oh, okay, this is a running, this is a process. I mean, this is a program. I can run it. I can execute it. Other than this file, no, it doesn't understand anything else.
Mm-hmm.
So Windows is designed and developed such that, okay, I know now each instruction from this executable file, I know how to translate it to assembly, from assembly to hardware. That is already built in.
Okay.
It's just that if I come and speak to you in Tamil or Malayalam, you don't get it. So the Shri as a person is designed to understand English. So you better give me English executables.
Mm-hmm.
The same like if it is Linux, you have the file name as ELF. So now to get to this, your source code to ELF file, you need these all other applications to make it happen. Now this entire set, right? So translating that every time is going to be a difficult stuff. So therefore, all this is packaged and given to you as GCC. GCC is a GNU, okay, GNU C compiler. So when you say GCC file name dot C, what it gives you is a file with a which is in a ELF format. So
Mm-hmm.
direct output. If your syntax and all that is right, if your inclusion of libraries, all that is right. So by default, it gives you a new name to it, a dot out, and then which is ready to run on the OS. You can now go onto your prompt and say a dot out and enter. Now your program has become a process.
Got it.
And similarly, when you go onto Windows, right? So you say GCC, but there is a name, different name for the company, GCC hello dot c, what it gives you, it doesn't give you a dot out, but it gives you hello dot exe. This is a new file it creates with the same file name, right?
Mm-hmm.
So that's the difference. Let's go back. Now, now GCC, I'll give first proc.c. Okay, nothing happened. That's a good sign here. Now, if you see ls, you see I have two files. A dot out has been created for you. Now, if I want to type a dot out, so which dot slash. So interesting. Why is it saying type a dot out? It's not found. Let us go. A dot out is read, write, execute, read, execute, read, execute, which means that I can actually run it. Executable permission is there. This is an executable file, but when I say it says command not found.
Mm-hmm.
Interesting, right? So file is there, I can see it, and it says command not found. So that is where I need to give the relative absolute path of it. So wherever it is, you locate it. So dot slash always represents the current location.
Okay.
Hello, hello, this is my very first program. Or you source it. Okay, I can do chmod. I'll come back to that part of how to run without this. So that's how you run your first program in Linux environment. What I'm using is Mac actually. So, but it's still, this is also based on Linux operating system. Okay, so now going on to what you have done. So GCC first program, and I can give a new name instead of a dot out. Okay, and I say first prog. So now what it does, I'll remove a dot out. This is coming from old. Okay, first prog. So now this is an executable. So ls-l. Yes. So if you see xxx, this is executable. So I renamed the executable name with this command.
Mm-hmm.
That is gcc hyphen o is okay. Give the output file name as this. That's what I'm indicating.
Okay.
All right. Okay. So now I can run the same this. This is the important part to understand, and because you will be writing source code in plain English like what we have done, and we will also be writing in assembly language over a period of time, because assembly language comes in here in this part. So you write the source code same way, right? Okay, main, and then printf. Here you write instructions directly, the registries. You know, move. There are certain instructions, just like C instructions, you have assembly language instructions. So it's a set of statements again to instruct the computer in a certain way. Now you have source code saying, okay, If I'm writing it in C, I use printf, good, to print something. If I am using assembly language, what should I use?
System.out.print.
No, not for assembly language. So assembly
Oh,
language,
echo.
sorry,
Echo.
yeah, I think it's echo or disp, disp. I need to check
Okay.
it as well. So that's the stuff, right? So it's a set of instructions, either written C language or assembly language. You write there. So what we are going to learn is a syntax. Don't treat it as oh such a big thing or no. It's a set of instructions. When you learn a
Mhm.
new language, Spanish, you learn new words. Uh, so just like that. So C, C++, Java, Python, assembly language all belong to the same. Learning new words, learning new syntax. Now you might get a question: why do I need to write assembly code inside my C code
Mhm.
when I know that Python? When I know Python is such an easy language, or Java is an easy language. Why, Venki? Why should I learn C? It seems to be a little difficult. Okay, I'll compromise. I'll learn C. Why again assembly language? It comes as if like an alien language to me. Because see, as you see, the as you're writing, you're going close to the hardware. The closer your program runs from the hardware, the faster it is.
Mhm.
Here, yeah, it's slow. Uh, In fact, I'll write it this way. So Python, Java. So yeah, it's very easy for end users to write. Even my daughter can write it. She's learning it actually in her eighth grade. Now, Java may be a little difficult, but yes, I can still write it. C, yeah, complicated, but what it offers, it is going close to the operating system and hardware. Therefore, the layers of translation is not required from.
Okay.
Therefore, it is super fast, and therefore
Mhm.
it is used in all scientific operations, be it your rocket launching and rocket science, or your embedded operating systems, your cars, the internal softwares, everything uses C and assembly language so that the precision is achieved, the speed is achieved. And see, any second of delay could be catastrophic.
Mhm.
So therefore, we don't want to take chance. So in that cases, we go for assembly.
Okay. Got it.
And C gives you rich set of libraries on top of assembly. So you would use rich set of libraries for your programming, embedded programming, all your devices, right, including phone, everything has C programming in it. And the tablets that I use, like the XP pen that I'm writing, is also uses these C programming language. So any device that you connect, right? Any device that you connect to your laptop via USB, you connect, right? So when you connect via USB, now how is this able to identify that you are device is connected to your laptop? How do I know that? There is something called device driver. This is again a software.
Mhm.
This device driver is written in mostly C language.
Okay.
This interacts with the OS and hardware directly. Therefore, you are able to connect device and use it for the purpose it is. So device drivers are usually developed by the product vendors. So if Apple is released a new device, they are expected to write the device driver and release it into the market. If Microsoft
Mhm.
added a new mouse, they are supposed to release the device driver. So the developers who work for Microsoft work in the device driver team are the ones who are responsible for developing it.
Mhm.
So that's the purpose of how learning multiple languages helps. Why should I learn C assembly language when I have Python and Java, the easier ones? And how does the process of source code and compilation work? The different formats and all that is covered here.
Oh.